Okay, this is the second part of the quality management. In here, we expect to identify the most desirable things related to the statistical process controls SPCs. So in here we expect to identify what are the tools related to the SPC. Here I mentioned in previous I mentioned that there are seven tools for the SPCs, statistical process control techniques related to the manufacturing industry. The first one is histogram. The histogram is the bar graph which shows the frequency distribution of the data of the group about the central value. The histogram is an important diagnostic tool because it gives a bird's eye view of the variation in the data set. In here histogram is actually, this is a graph and a graphical view, and it is also we can using this histogram we can represent our data in the very holistic view. That's the reason these histograms we call the bird's eye view. And this is the examples for the histogram charts. It is the bar charts, and histogram is formed by marking of intervals on the real number line on which the measurements fall, and then constructing a bar over each interval with highest equal to the frequency or relative frequency. It is representing the frequency or relative frequency data using the graphical way, using the bar chart simply. The second one is the check sheet. Check sheet is used for checking the quality measurements and checking or point out the quality measurements using the sheets. That's we call the check sheet. A check sheet is the data gathering format prepared in such a way that the data collections when designing the check sheet is important to clearly specify the type of data to be collected, part operation number, the date, the name of the analyst, and any other useful information, case of poor performance, and etc. Actually, this is the information gathering chart and information gathering sheet, and it is it has a very describable way to identifying and gathering data. This is the example for the check sheet. And the third one is the Pareto diagram. The primary purpose to use the Pareto diagram is to focus improvement effect on the most important cases by identifying the vital few and trivial many cases. The Pareto diagram is also we are using for to identifying the cases, what are affecting for the quality functions, and also the getting the details and develop the required remedies for that. The Pareto chart indicate the following: what are the problem, which problem need to be tackled in the priority, and what is the percentage of the total does not each problem present. It is actually presenting, it is also the graphical way, and also we can describe it as the mathematical numerics also. As an example, so in the sales part we can use the Pareto diagram for identifying the customer complaint analysis, warranty cost, market share, and etc. The production and safety side is also the same. And next slide, I point out how to draw the Pareto diagram. Actually, this is not included on syllabus, but I put in for your further requirements, further references. And next one is case and effect diagram, or a Ishikawa or a fishbone diagram. Why we call it as the fishbone means that diagram is like a fish bone or a fish. The case and effect diagram, also known as Ishikawa diagram or a fishbone diagram, in a pictorial representation of all possible cases which are supported to influence an effect which is under consideration. That means using the case and effect diagram, we can identify what are the root cases related to the we identified cases or effect. And This is the how to construct the CNE diagram or a cause and effect diagram, and this is the this is the steps for constructing the cause and effect diagram, and this is the example for cause and effect diagram. We are the defects on the task. We identify that there are 5 cases related to that defects of the task: machines, materials, method, measurements, and the personals. And also we identify what are the cases of the machines, what are the cases of the materials, what are the root cases of the methods and the measurements and the person. So identifying the final root cases we can use this cause and effect diagram or a Ishikawa diagram. The next one is defect consideration diagram. A defect consideration concentration diagram. A defect concentration diagram is the picture of the unit showing all relevant waves. Various type of defects are drawn in the picture, and the diagram is analyzed to determine whether the location of the defects in the unit. Actually, this is the diagram and the graphical and the pictorial representations and defect concentration diagrams we can identify using this one. Where the defect is, where the problem or where the defect is location lies and the things. And scatter diagrams, normally we can scatter diagrams, the line progression lines also is using related to these scatter diagrams. This scatter diagram is useful plot for identifying the potential relationship between the two variables. Actually positive relationship, negative relationship is no relationship. This is the fully algorithm representations. This is most statistical most relevant to statistical representation rather than the other SPC tools. And also the finally control charts. Control charts is we also use for the process controlling. A graphical display of data over time. Data are displayed in time sequences in which they occurred or measured, used to differentiate common cases variations from the special case variations. Control charts combine numerical and graphical description of the data with use of sampling distributions. Normal distribution is base for control charts, we know, and I believe you know the normal distribution. You can learn in this normal distribution related to the mathematics and statistical subjects. Normally we use the normal distribution charts for this as the control charts in the quality management. Goal of using chart is achieve and maintain the process stability. And previously we called the quality management has the primary goal the process stability and capability increase and the things. So using these control charts we can maintain the process stability. And the basic components of the process control charts. A control chart always has the central line, usually mathematical average of all sample plotted, and upper control and lower control limits is defining the concentrate of common variations or range of applicable variations. Performance data plotted over time. Line are determined from the historical data. Okay, this is the these graphs are examples for the control charts. Actually, the control chart has the central line. It is the middle line, and also it has the upper control and lower control lines. The upper control and lower control lines are basically we are estimating and we are determining based on the value of the fluctuation of these control charts. The upper line is we are drawing in the upside over the control line, and lower control line we are drawing the under in the central line. And When to use the control charts? Normally, what are the at what time we can use for these control charts? Controlling ongoing process by finding and correcting problems as they occur. We can use the control charts for the correcting problems too, and predicting the expected range of outcomes from the process, and we can identify the range of the product and determining whether a process is stable. In statistical control, what is the process is stable part, and analyzing patterns of process variations from the special cases or common cases and special cases to identify the stability of the process, and also to identify the expected range of the product and controlling the ongoing processes and the things. We can use the control chart. And the final one is determining whether the quality improvement project should aim to prevent specific problem or to make fundamental change in the processes. To change our production processes or say service delivery processes, we can use these control charts. Furthermore, okay, this is the basic procedure of the control charts. Choose the appropriate control chart for the data and determining the appropriate time period for collecting and plotting data. Collected data, constructed the chart and analyze the data. Look for out of control signals on the control chart. When one is identified, mark it on the chart and investigate the case. Document what you learned, the case and how it was corrected, and continue to plot data as they generated. As each new data point is plotted, check for new out of control signals. Actually, control chart procedure is for your further informations. Okay, this is the general model. Actually, I tell you, normally control chart has the central line, upper control line and lower control line. CL is the central line or control line, and UCL is upper control and LCL is the lower control level. Where the in here I also point out how this what are the meaning of these equations, functions. What are the meaning of these functions in the general model? And in the there are two type of the control charts. These are the two types of control charts: variable control charts and attribute control charts. Variable control charts, variable data are measured on the continuous scale. For example, time, weight, distance, or the temperature can be measured in fractions or decimals and applied to data with continuous distribution. Normally, variable control charts we can use for the continuous distributions, and attribute control charts is attribute data are counted and cannot have fractions or decimals. Attribute data arise when you are determining only for presence or absence of the something, success or failure, accept or reject, correct or not correct. For example, a report can have 4 errors or 5 errors, but it cannot have 4 and a half errors. Actually, applied for data discrete distribution. Normally, variable control charts we are using for continuous distribution. Attributes control charts we are using for discrete distributions. These are the end of the quality management subject. In here we identify what is the quality definitions, dimension, types, perspective of the quality management, and manufacturing related to the SPC tools, and also the control charts and the things. So this is the end of this lesson, and thank you very much.